Thank you for the introduction. Yes, I'm a former thought worker as well, so I'm an extended friend of the family, if you wish, and I currently am an enterprise strategist with Amazon Web Services. And as you mentioned, I like to write and I like to think about architecture. And today's talk is actually a mix of two things. The one is really thinking about what it means to be an architect, and that's the notion of the architect elevator, but also apply that to cloud, because cloud has really changed the way we develop applications and operate applications more than most any other technology in recent history, right? So it's definitely an interesting one to apply the notion of an architect towards. And architects are like sort of a little bit special animals. I think one later talk, Eric will talk about having architecture without architects. I don't think there's anything fundamentally wrong with being an architect, but we often have a hard time agreeing of what it means to be an architect. So I often like to look at the popular media and see like, well, how do they actually portray an architect? Like what are people told that architects are like? And this is sort of, if we dig up a little bit our history, this is probably the most famous architect from The Matrix, right? And is this like, A, it's an old guy, and B, it's sort of somebody who makes all the decisions and sort of knows everything. And I always remind people of, well, two facts, actually. The one thing is, this is not a human being, right? This is the machines, the story of The Matrix, right? So this all-knowing architect person isn't actually something you can aspire to. And the second comment is, the second comment in the movie is, of course, that the Oracle really kind of wins, the architect doesn't win. So maybe not the perfect role model. Sticking with the movies, anybody has read the novel or seen the movie High Rise, it's a similar notion of an architect. Okay, it's also an old guy, right? I don't know what's with that. And the other part, it's again this notion of this utopian vision this architect has of building the perfect structure. And of course, it ends in absolute mayhem and goes totally wrong. So perhaps this isn't a great role model to aspire to either. And then when people think about me as an architect, they often think more about this guy, right? It has a little bit to do with the haircut. It has a little bit to do with more like experimenting and trying and figuring things out. And I'm perhaps more that kind of architect. So so they are looking at the media, people have weird visions of architect. Let's find our own version of what an architect should be doing. And yes, definitely there should not be all white-haired guys, that's for sure. So if you look sort of my direction and my employer's direction, right, cloud providers, cloud service providers, we also have a definition of architect. And usually it's bypassing a certification, right? You become a professional architect, community architect. There's many cloud certifications you acquire. And I think they're actually quite useful, but I compare them more to acquiring a driver's license, right? It's good. It shows you know the rules of the road, right? You're qualified, you studied, you practice, right? You're safe to participate in traffic or in building systems. So it's a good entry-level qualification. Now, the reality is, though, that when you look at implementing cloud solutions, especially at a large scale, which I do a lot, it looks a lot more like this, right? And having a driver's license is perhaps useful, but it's by no means sufficient to participate in a Formula One race. And hopefully we're not creating carnage either while we are architecting. So that one has some advantages, but I wouldn't name a person who just has the certification owe you a better version of what, in my view, it means to be an architect. And it has changed a lot, right? Cloud computing is certainly one aspect. Methods, like DevOps and agile have really influenced the way we work. Then we have pandemics and many other things, right? So the environment we operate in has dramatically changed. That's why I think the role of the architect also should be changing quite a bit. And as so often, the problem is not inside the pieces, but the problem is with connecting the different pieces. What I see in organizations when there's a high rate of change, right? New technology, new business, shifts in channels and business models, right? They want to be innovative, a lot of things going on. Usually the problems are because the pieces aren't properly connected. And that's why I often use the picture of a skyscraper. Traditional large organizations, they're layered. Common architecture pattern. We also layer many systems, which you saw layering micro front ends. Yeah, we're also layering systems. It has great advantages, but also disadvantages. And one disadvantage is that the travel time from one end to the other can go up, and that also the message might change along the way. And therefore, I think the most important role architects can play these days is to be a connecting element. Rather than going across all these floors one by one, architects should really be riding the elevator. We need to move across the different levels and need to be a better connecting element. Now that transcends both the organization as well as the systems architecture. I often say, if you're attempting a large-scale system architecture, you will not be successful unless you can also influence the organization. But the highlight is, as architects, we actually know usually more about organizations than we initially believe. So you need to live in both worlds. You need to communicate at the different levels. You know, people have different priorities, different incentives, so they need to be spoken to slightly differently. But of course, it doesn't help to tell them a completely different story, right? In the end, it's about linking the levels, but telling the story in a different way. And what's important to me is that the value as an architect isn't measured by which floor you attach to. Now, I used to be a chief architect. That sounds really grandiose, but in the end, the value comes by how many floors you can cover. And if that's the top half of the skyscraper, and if that's the bottom half of the skyscraper, makes no difference. You bring equally much value. However, if you only sit at one floor and sort of, requirements come in and you sort of review and put a few notes and pass it on to the next floor, right, probably the value you bring in this scenario isn't quite as big. Now you might ask, like, okay, do we need this elevator? Why don't we just take the skyscraper and flatten it out? Well, and the reality is, just in a real skyscraper, if you try to take a few floors out, you don't get a bungalow, you get a pile of rubble, right? There's existing processes, organizational knowledge. It's not that easy to take layers out of a skyscraper, and it's equally not easy to take a layer out of an organization. So what I want to do is apply this model to cloud computing, right? How do we ride the architect elevator when we operate in the cloud? And we start on the top and we ride the elevator down. We start in the penthouse. And the question that we often have is, well, how do you explain technology, like Docker containers, Kubernetes, Helm charts, service meshes, Istio, whatever all you have, to the CEO, right? CFO, COO, to the executive board. And in the past, the answer would have been, they don't really need to know all that detail, right? It's just like what type of mainframe you buy is whatever. As long as they sign the bill and the thing runs, the board doesn't have to deal with it. But I believe that has changed a lot with the cloud, because the cloud is becoming a big business enabler and business driver, and often their competitors thrive on it. So the board needs to have some idea of what's going on in the engine room. Now, how do you explain this? And I probably have 50 different versions that I tried, because I meet with a lot of executives. And in the end, I came to describing that cloud, the most powerful thing cloud computing can do is remove constraints. And remember, we on the penthouse, we're speaking to decision makers and executives, and they all know that IT in the past was managed by constraints. Right? We need to harmonize, standardize, reduce complexity. We want to be compliant with regulation or our internal standards. We want to reduce costs, right? Those are the constraints that apply to any CIO. Ask any CIO, they will say, oh yeah, I can sing that song very well. I get that from my boss all the time. At the same time, the business comes, it's like, well, we live in interesting times. We need to have innovation. We need to have more customization for our distant customer groups. We need to move faster, right? And the question is, how do you make those two ends meet? And traditionally, they were seen as opposites, right? If you're standardized, you take innovation away, you have less flexibility, right? If you reduce cost, you can't necessarily customize to different situations. And if you want to be compliant and have high quality, you need to be moving slowly. Now, luckily, we debunked essentially all of them. And we as architects know what the mechanisms behind these things are. Platforms are highly standardized things that actually boost innovation. And I often say AWS is a great example. I sometimes like to poke our customers a little bit and say, the AWS you're getting is the same AWS your competitors getting. And they're like, oh, it's like, yeah, well, that's in the end. It's a platform. It's built on scale. But look at what people build on top of it, right? It's been the biggest innovation booster we had in IT probably in the last decade and a half. So it can be done, but you standardize, but at the same time have high levels of innovation. Well, and of course, we know that speed actually doesn't have to reduce quality. Things like automation and shift left and CI/CD actually makes you move faster and increases quality, right? And if you have low friction in your system, you can move quickly. You maybe have even machine learning models. You can also be highly customized, and it doesn't cost much. We don't live in the days of Ford Model T anymore, right? If people remember 100 and some years ago, Ford Model T was only available in black because that made it cheaper. Modern software delivery is not a Ford Model T. You can have it any color you want, and it doesn't cost you a penny more. So this is when you look at architects in a penthouse, it's about explaining how the technology solves acute business problems. And you can hint at how it does that, but it's most important for people to understand it's like, yes, I can break out of some of these things that used to be perceived as sort of, I have to choose between left and right. Now I can have both. And that shows how powerful having these kind of things is. To be honest, I always remind people also how different the cloud is, right? Like, obviously, this doesn't happen at a push of a button. You can do amazing things, right, with these kind of infrastructures and application runtimes, but it is very different. And you have to remember that enterprises' relationship with technology usually starts at procurement, right? We always think about, we're there to deliver a solution and we come on site and build and code away. It's like, no, the story started much earlier. Somebody purchased and signed the license agreement. So in the penthouse, that is a very important aspect. That's why people talk about CapEx and OpEx and enterprise discounts and how long the terms are and liabilities and is this a US corporation and where is the seat of court and like a lot of stuff. Very important for a large organization because this can be 10 million, this can be 50, this can be $100 billion. People want to make sure it's done properly. So I don't need to probably go through all of these. It's straight from the cloud strategy book, but basically it shows that all of these are more or less the opposite of each other, right? On one hand, you want to predict exactly how much it's going to cost you. On the other hand, you actually don't want to predict because you want to be elastic. You want to spend less if you need less, and you're okay to spend more when you need more because it's giving you the value. It's like exactly the opposite view. So these are the things that architects see to in the penthouse. And you might say like, oh, isn't this a little fuzzy? Kind of, isn't this sort of where the management consultants come in? Yeah, that might be true. On the other hand, if these things are out of whack, like if the leadership doesn't see the value of this technology, if they don't understand how big the shift is, and if procurement doesn't understand like how to deal with this new kind of technology, basically no IT delivery can save you, right? Basically, if the skyscraper is like, if the top doesn't sit on the base, right, whatever you do in the engine room is in the end not going to be helpful. So it is very important that this type of alignment starts up in the penthouse. And there's good architects popping in there every once in a while and making sure that that is actually taking place is a highly valuable exercise. Now, if you take the elevator slightly a little bit down, it's time to make decisions, right? And the subtitle of my book is A Decision-Based Approach to Strategy. Now, I'll come back more later why decisions to me are so important. Now, people think like, well, decision isn't that complicated. You have some alternatives, right? And you pick one of the options. And I often say at this point, many large organizations already made two mistakes. The one is they often don't know when they're making a decision. I have a lot of examples of you say, oh, but we can't do this because X, Y, Z. I'm like, well, who decided X, Y, Z? And then nobody knows. It's like, apparently they decided to do X, Y, Z, but never consciously made a decision. Big pitfall. If you deal with high levels of complexity, happens all the time. And the second one is, do we have all the options on the table? How many alternatives are there? Is it really only 3? Is it 4? Also, very often we blindsided there by complexity. So let's assume we did that properly. We make a conscious decision. We know what all the alternatives are. Now it's time to decide, right? That leaves us with the question, how do we do that? And what I see in the penthouse, decision consistency is very important. Because if you optimize each decision, you run into an interesting problem. And that problem is called the sum of local optima is rarely a global optimum. So you can make a series of very good decisions and basically paint yourself totally in a corner, or the other variant I see a lot, you keep going in circles. So in order to keep you out of that, you need a strategy. And based on the strategy, you need some principles, right? You need to value some things over other things, like the Agile Manifesto is always a great way of showing like good principles that say, hey, this is important to us. Then it's like short-term value delivery is more important to us than perfection, maybe, right? We'll fix it later, but if we never deliver value, you might never even get there, right? Or we might say like using one cloud properly, is for us more important than having ultimate flexibility cross cloud. Could also be a very viable principle. Short path to value. Do it right once and then make it complicated later, because otherwise you might never get there. But you could also have principle. Developer experience is a very high priority for us, because if our developers are not happy, they go somewhere else, and that great cloud will not do much for us. So many ways you can make principles, and then those are the ones that actually guide your decisions. So this is a nice bridge across the levels in the skyscraper, right? This speaks to executives, right? That even if the consultants have just come and shown all their 2x2 matrices, if you come with a framework like this, they say, okay, I get this, but at the same time, you can link to the actual decisions you're making, right? Do you want to have a hosted Kubernetes cluster, or do you want to manage yourself, or is it serverless, or is it containers, right? Like suddenly you can fold these things into like, do we have a principle that tells us what to choose? Maybe you have a principle, we want to do the minimum amount of operations ourselves. Okay, well then maybe a managed cluster or serverless is the better choice than doing it yourself, but it's guided on a principle, right? And this is the way how you get consistency and clarity into your decisions, because it's very good to have management on board so they understand the ramifications of the decision, right? There's always trade-offs, right? So it's very good for them to understand the trade-offs, because you don't want surprises later. Here, a very specific example, right? We go on the elevator down. Many people have heard in the cloud, how do you migrate applications? There's a 6 or 7 hours, depending which version you read. It's like, right, you retire, or retain, you rehost, re-architect, you re-platform. There's many different arts. It's basically ranging from, throw it away or leave it as it is to completely redo it. And that's great, right? That's a nice decision framework. Actually, the former head of our Department of Enterprise Strategists, documented this first. But what I remind folks is decisions are not single points in time. You don't take an application and say, oh, I'm going to rehost it. Because what are you going to do after you rehost it? More likely than not, you're going to do something else. So what I like to do is find more powerful decision models, right? That's what architects do, right? They're very easy to look at. You say like, oh, I have this migration axis, like when do I move it from on-premises to the cloud, and how much do I modernize? Now, suddenly this thing has 2 dimensions, and I can plot a path. It's like, yeah, maybe I just move it over lift and shift, right? But I'm okay. I replace my database, with RDS or maybe Aurora, right? So I get a little bit more operability in there. But then in a later step, I containerize, I get better monitoring, right? I get better automation, auto scaling, but each of these things sort of moves up or moves out a little bit on the scale. So architects can actually, we don't need to, what I was going to say is, we don't need to always give people the perfect answer. I think a lot of the value we bring in the Penthouse is sharing the decision models. It's like, well, here's the things we can do. Let's jointly decide what is best for us, and then depict it in a way that's very obvious. I always say, if this model looks trivial, that's good, right? Because models are supposed to simplify, not make it more complex. So if you have a model that makes the decision look simpler, that is actually a great thing, because you have a wider audience who understands the decisions and the trade-offs that were made, right? So if you're somewhere in this path, they don't say, oh, but why isn't my thing completely cloud native? He's like, well, because we had step 2 and 5, right? And the cloud native thing comes in 4. And they're like, oh, okay, I get it, right? So this transparency buys you a lot. It's time to ride the elevator down into the middle floors. And one great saying I often have is, when do you know whether you produced an architecture, right? And the one question that is the one answer that's the false answer is, well, architecture isn't a list of products, right? So if somebody says like, what's your architecture? And you rattle off various products, I would almost universally say that is not the architecture. That's a set of ingredients. Maybe they make a tasty meal, maybe they don't, right? The architect is more like the chef, right? The cook, it's how you put these things together. So to me, it's much more interesting about whether an architecture includes decisions, right? We already heard about decisions. And that's why I like to use the simple test, right? I ask people, is this an architecture? And many people say yes, because all the pieces are there, right? The components, the relationships, the roofs, the doors, the windows. But there's a good question to ask when you work for a large organization. The question isn't, is this architecture? It's a little bit abstract. You make a simpler question. Would I have paid an architect for this? And then there's no more much debate, right? Then it's like, no, because there is no non-obvious decisions. All the decisions are obvious. Yes, the door is on the ground, great. The windows are in the wall, fantastic. And the roof is on the top. It's like, great, yeah. But I'm not paying an architect for this because I'm looking for trade-offs. I'm looking for non-obvious decisions. And that's why I raised the bar for producing architecture. Here's a counterexample, equally poorly drawn from my book. This is a house that has glass walls, but reason for that, right? Because it's a hot climate, so we don't want the sun to blast in the summer, but in the winter, when the sun is low on the horizon, we're actually quite happy for the sun to come in. Well, these houses actually exist. They're considered some of the most iconic buildings. This one is in Los Angeles, right? You can tour this, you can pay money to visit it. It's like an architectural icon. So it takes a few decisions only to define great architecture. And again, great architecture isn't complicated. It is based on a few fundamental decisions and trade-offs that were made. But the trade-off here is maybe, oh, my living room is a little bit smaller because the big roof overhead, or there might be many other trade-offs, right? Privacy might be less, right? That's the job of the architect. All right, so we have major decisions in here. We consider the context, right? This house is not in Singapore because the summer-winter thing, but the sun doesn't work where we live, right? And it's not complicated. It is actually fairly apparent what was done here. Now, I have another favorite definition of architecture, and that is selling options. Making decisions is great, but equally great, it's to not make decisions. And not making decisions means deferring decisions, not just ignoring them. And deferring decisions has a name. That's called buying an option, acquiring an option, because it allows you to make the decision in the future. And making decisions in the future has a great advantage because in the future, you're smarter, right? We talk about your last responsible moment and things like that. That is all about deferring decisions. Now, architects sell such options. My favorite example, back to cloud, is server sizing, hardware sizing. How much hardware do we need for your application to properly run? Right? Many of you might not remember, but in the old days, people had hardware sizing teams, right? They would actually like calculate and estimate, and in the end, they always get it wrong because how could you possibly predict exactly how much hardware you need? Well, Cloud Architect brings a very nice option. It is called horizontal scaling and elastic infrastructure, right? So you defer the decision, and it becomes very easy to make the decision because you need more hardware, you add more hardware, you have too much, you take it away. So selling this option has a clear value. You're smarter now, it's easier to make the decision, you make a much better decision. So architecture as option seller has real value. It's not a nice to have. Now the keyword here is we're selling options. It doesn't say we are donating options. We're not giving them away. So there's a cost, and the cost is often complexity. Right, a horizontally scalable solution is slightly more complex, right? You need state management and other things, right? You need to make sure you have everything automated, etc. Right? You need a load balancer, right? So there's a few more things that you just need to do, right? So you figure out, is the option worth buying or not? And that is the essence of architecture, right? So you have an options trading marketplace. As an architect, you can bring options and you discuss with the business which option is worth buying. Now, here's an interesting option that a lot of people like, and that is called lock-in, or that's something they like to avoid by having more options. How easy is it for me to switch from one product to another? So that is a nice option to have. But like I said, as I just said, the options are never free. So first you analyze of, do I get value out of being locked in, right? Of not using the option. And often you actually do get, right? Things are a little bit simpler. It's easier. I sometimes get rewarded. Well, a lot of people are happily locked into the iPhone Apple ecosystem, right? It's like totally fine. They don't need to buy a Samsung tomorrow. I'm on the other end, right? I'm an Android person, and the ecosystem makes that actually pretty comfortable for you to be locked in there. So it's not the battle between good and evil, right? It's about making trade-offs, right? And understanding Lock-in has many names, right? Open source doesn't mean you're not locked in. You're not locked into the vendor maybe, but you're still locked into the product, and you're still locked into the architecture, right? You're still locked into many things. So architects see the dimensions, right? It's never a single dimension. And we also see the trade-offs, right? There's a benefit, but there's also a cost. And that leads me to, so my last point of the middle floors, and that is the extrema of these curves are rarely ever at the optimum. It's always about you invest up front, you turn one dial to get something else down. It's like, okay, I make my stuff a little bit more abstraction layers, so I have a lower switching costs, right? It's almost always these kind of trade-offs. Now, these kind of trade-offs, they lead to, well, it's actually sort of, this is the cost. So imagine the benefit curve is the other way around, right? The benefit is almost always a convex curve. And that means that the extrema, left and right, are never the optimum. So that's when architects come and say, oh, it's got to be like cloud native something always, or it's never going to be this, or I can't be locked in, or it has to be go or I go bust, right? That is almost always wrong, because the optimum is never at the one extreme or the other. Microservices are great, but other things are also great in other situations. So with that, it's time to go the elevator down into the bottom floor. I don't have as much here actually, because there's tons of material on how to deal with cloud stuff from the engine room perspective. What I always like to highlight is just a handful of things. One of them is that we talk about availability very differently in the cloud. In the past, we make robust systems. Those are systems that don't break, and it's great until they do break. So in the cloud, we're much more looking at resilience. These are systems that we don't like them to break, but if they break, we can actually deal with it. And the key difference here is this is no longer an infrastructure topic, but it's an infrastructure and application topic. So we need to think and work differently. And the amazing thing we can do, probably a topic for another talk, is once you're resilient, we can actually inject failure into our system and become more resilient. And if that seems like an odd thing to do, we live in the age of vaccinations. Vaccinations are, in fact, injecting disturbances into your body as a system to make you more resilient. And that's actually a fantastic thing. So being anti-fragile is something you need to work towards for your organizational system, but actually it's an amazing state to be in. And as odd as it sounds, the quote there is, always being in a failing state is great, because if something fails, nothing changes. Right? So these are the things as architects, we can have clever slogans sometimes. These are the things that we can work towards down in the engine room. Another one is we talk about ilities so much. We have like scalability and portability, maintainability, all these ilities. The ility that I think is underappreciated is disposability. How easy it is to throw one thing away and recreate it, right? Infrastructure as code, I think Keith is coming up later, right? He will tell us a lot about how to implement disposability. And if you're an engine room cloud architect, I would take this as one of the most attractive ilities you can give your system. And with that, we are near the end already. A lot of people talk about, now, what does a cloud application have to look like? Yeah, there's the 12 factors around these cloud native things. You always like make a little fun of this. It's like, yeah, how can you migrate something to the cloud and be cloud native? Aren't you actually a cloud immigrant? And I'm happy to be a cloud immigrant. So I tend to have a much simpler view of some of these things and much more in natural terms of saying, yes, let things be frugal with resources, relocatability, easy to move around, restart another instance, observability. You can see these things. My old friend Jean-Francois wrote a whole chapter in my book about this. But again, what I want to highlight here perhaps is, these are not like very complicated things. These are things that are easy to grasp and remember, but they're relevant down in the engine room. And no cloud management in the engine room without cost. We all know this. We go to the supermarket to buy a jug of milk and we come out and it was $20. So we all learned little items add up. The cloud is elastic, but the cloud isn't free, right? So engine room cloud architects have a new ability or new ility, and that is the cost visibility and the cost controllability. So I invite cloud architects in the engine room to also design their things to minimize cost, right? Elastic infrastructure goes both ways. You can reduce your costs, but now, of course, you also have the responsibility to watch the costs carefully. Don't spool up a giant demo thing on the weekend and let it run, right, and come back from vacation 3 weeks later to see the bill. So hopefully there was a good whirlwind tour, right, of what it means to be an architect in modern times, right, being able to cover the different levels, right, applying that to cloud architecture, and it comes to justifying and explaining why cloud computing is so powerful, to executives, down to like decision discipline and decision models, and think about switching costs and optimizing that, down into architecting solutions that work well in this environment, where we talk about things like anti-fragility, and then very last, of course, right, we have cost control. That means we also have cost responsibility. Now, if this piqued your interest, right, I invite you to follow up the dialogue, right? I'm fairly active on LinkedIn. You can find me on Twitter. There's a, almost chopped off at the bottom here, there's a coupon code for the book, if you like. And I thank you for your attention. Thank you very much.